The real value of a simulation model is obtained when we analyze how the system performs, introducing all the detail that the real situation requires. In our case, for example, we can change back our data to reflect the fact that our tasks have some variability, which we have here, ranging from 10 to 25, which is the largest value for that variability. And I also changed the buffer capacity. I switched all the values to 0 to reflect the fact that we don't have any room in between stations. And now we can run our model, and if we fast forward it, okay, we see this bar here advancing, and now we see that the cycle time is 20.4 and the hourly production is 2.94 instead of 3. So this way we can evaluate that loss of capacity due to the fact that there is variability and we are going to produce less, and accordingly we are going to make less money. We could try to isolate the two effects and see what would happen if, instead of having a capacity of 0, what if we increased it. I'm going to put infinity for all of these properties so that we check what could happen if we increase the capacity so as to not having any trouble when it comes to storing parts in between two stations. And if we run the model again, we expect something in between the two values we obtained previously. So this allows us to see if it is worth the investment to make some room in between stations. So we are now closer to 20 minutes cycle time, and we are very, very close to those 3 items per hour. And if we translate that into money, we can analyze the payback of that investment. Okay, we could also analyze the impact of reducing the variability. Imagine that we can train operators in these stations so that these values here are reduced and we have less variability. Again, we might estimate the impact in terms of the production we have. And I'm not going to do that now, but we can also explore what happens if we duplicate this station or any other one, or we use more than, I'm going to remove this, if we put 5, 6 or 7 stations. In any of these cases, prior to running the model, we would need to find an assignment for the tasks to these stations. If we have 7, we have probably a significantly reduction in the cycle time because we distribute all tasks among these 7 stations, and we could do that manually, which is not very advisable, or we can go back to our optimization model, let the model know that we have 7 stations, get a solution, we introduce that within our data, and we run the model to have a better estimate of the capacity. So I hope this video, this series of videos along with the previous series, allows you to understand better how optimization and simulation provide value. Each is valuable per se, and they can be combined into a more profound and in-depth analysis. And it depends on the situation and the data and what the problem is to decide whether one option is better than the other, or whether we should combine them to have a better estimate. Because if we are having much money at risk, it's worth investing in developing these models to have a very well calculated number here that justifies any changes in our system. And having even 2 models might be more than worth it. Again, I hope you enjoyed these videos and you found them interesting, and see you next time. Thank you very much. Bye bye.